This is section 1.4, day 1, and today we're going to be talking about how to shift graphs. So we're going to do some shifting, reflecting, and stretching graphs in different ways. And before we can start that conversation, we have to talk about what we call our common functions, or what I call them is our parent functions. So every equation that looks like y equals x, they all look like this, is how they start out. And then we adjust them, we change their slope, we add 5 and move it up, or we throw a negative in front and we tip it down. So every basic y equals x graph looks like this to start, and then we move it from there. So we kind of consider this the parent. This is what everything starts off of, and then from there you can have different equations. So an absolute value function, all of them look like this. They all have that V shape, and the only thing that changes is if I slide it to the right, or flip it upside down, or make it skinnier or fatter. But every absolute value has that basic shape. All of the square root ones, they all look like this. They kind of start at 0, 0, and then they wing off in one direction. Again, until we slide it, or flip it, or move it, then its equation would change. But this is its base, this is its parent function. You're very familiar with parabolas, and all parabolas have that U shape, and they all look like this. Again, until you stretch it or shrink it or move it to the left or flip it upside down. But all parabolas start off looking like that. Two more, you've got a cubed function. I'm not sure how often you've ever seen this one, but a cubed function looks like this. And then its inverse, which is a cubed root function, just gets turned the other way. So those are your basic parent functions that we are going to be using in this class, and then we're going to talk the whole lesson today about how to move them. So the first kind we're going to do is reflecting. So we can reflect graphs or flip them. And so we're going to use the square root of x function because it's one of the easier ones to tell when there's a difference. So this is our basic square root of x function. And then, I'm going to grab some different colors. And then it says, can you please graph negative square root of x? And I'll make that be this nice blue color, negative square root of x. And if we have a negative outside of the function, what it does is it flips over the x-axis. So it flips downward, or flips over x. And then I'm sure you can tell what will happen if the negative is inside the function. So this one's inside the function. This will flip over the y. And the only reason I used that I used the square root function is because it's easier to see it move compared to the absolute value function which is just a V, and then if you flip it, it would just be a V again. So it's kind of hard to tell. So that's why we picked that one to demonstrate flips. And this type of transformation is called rigid because nothing about the shape changes in size or appearance. All I'm doing is just flipping it. So I maintain everything about it, I just flipped it over. That's called a rigid transformation. So skinny versus wide. There are some books out there that use like horizontal stretch or horizontal shrink, and I think those get a little confusing for students. So we mainly just talk about things getting kind of skinnier as a function or getting wider. So for this one, the easier one to look at is parabola. So I'm going to show you that. And this is your basic parabola, your baby that you've been graphing for a long time. And now we're going to talk about what will happen if I put a large number in front of it. So like a 3 or a 5 or a 7. So any whole number, anything, as long as that number in front is greater than a 1, then your graph will get skinnier. So as you think about it, for every value you're plugging in, if you plugged in a 1, you're going to get 3 times as high. So your graph will get skinnier. For the other one, then obviously, if you have a smaller number, anything between 0 and 1, you actually will get fatter. Or wider, I should say. It's a little more PC. Get wider. So what the concept is there is for every number that I plug in, I'm only going to get 1/3 as high. So it will be a lot wider. And these are called non-rigid because I'm actually changing the function. I'm changing its size and its shape, essentially, because I'm either making it skinnier or wider. So these are called non-rigid. The last kind of transformation we talk about is horizontal and vertical shifts. So literally moving the graph up and down. And a nice one to see that with is absolute value. So absolute value looks like a V. And that's your parent, so that's your original. Oh, I need more colors. I have more things to show you on this one. So the first one says, can you graph just x plus 3? So when the value that you're using is inside with the x, you affect the x. And this one does the opposite of what you think. So this is actually a left 3 move. So 1, 2, 3. And your whole graph would stay the same in terms of it's not changing shape. It just changed the location. As long as the number is inside with the x, it affects the x, so it moves along the x-axis. And you do the opposite of what it says, so this one will move right 3. 1, 2, 3. Drawing that. Oops, I missed it. Right there. Not bad. Then you've got one where the 3, or the number that we're using, is not inside of the function, that it's actually outside of the function. Now that affects the y, so this will be an up-down move. And these ones are just what they say. Excuse me, so that will be up 3. So I'll take my function and just move it up 3. And then hopefully logically, if we saw minus 3, that would be down 3. So taking my parent function is what I'm always moving. And there are all the different ways that you can translate, which is sliding the graph or moving it left, right, up, down. So those are all, oops, one more thing, sorry. This is called rigid again because nothing about the shape changed size. You did not adjust its size at all. All you did was pick it up and just move it around. So that's called a rigid. And these are all just the different types of ways that we are going to talk about and work with functions and moving them around.